Hi guys, today we're talking about periodic trends. The first thing to note, there are four main periodic trends: atomic radius, ionic radius, ionization energy, and electronegativity. Those periodic trends can be found based and caused based on the periodic table, placement on the periodic table, and do explain some of the reactions and reactivity we see. The first trend we're going to talk about is the atomic radius. And the definition of the atomic radius is that it is half the distance between adjacent nuclei in a crystal of the element. And that sounds like a lot of words to basically say if you look at a circle, because most atoms are circles, and you know a radius goes in the center to the end of the circle versus the diameter being the whole thing, it makes sense that a radius is basically half the distance between the two circles, which is basically a radius. And elements that occur as molecules. That means that you're not just looking at like an atom of, say, or a block of like sodium, but let's say we're looking at sodium chloride. It's half the distance between nuclei of identical atoms that are bonded together, and not necessarily just, elements that are bonded together. And the trend is it goes down from left to right. So if you're reading like a book on the periodic table and it goes from left to right, the atomic radius is decreasing simply because there's more valence electrons. And if you think of electrons as being like magnets, you have the positive center and the negative valence electrons. The bigger the positive and the bigger the negatives, they're going to pull closer together and get that tighter atomic radius. And they from top to bottom, they get bigger simply because there are more valence electrons. There's just more electrons. As you go down the periodic table, there's more electrons. Therefore, the radius is going to be bigger because there's more of it. So if you look at it, it decreases left to right, and it increases top to bottom. The next trend is the ionic radius. And this is an atom. First thing to know, that an ion is a bonded group of atoms that have either a positive or negative charge. A positive ion is called a cation, not a cation. That's C-A-T-I-O-N, a cation. And remember, cats meow positively. And the a negative ion is called an anion. That's A-N-I-O-N. And there's no good way or cute way of memorizing that, so it's just an anion. Cations have lost an electron. Anions have gained an electron. And the ionic radius is simply the atomic radius of an ion. Please remember, when ions are formed, you are always gaining or losing valence electrons. Cations have smaller atomic radiuses or ionic radiuses because they are losing electrons. So when you lose electrons, you get smaller. And anions have bigger ionic radiuses because they're gaining electrons. So they have more electrons, and so they get bigger. So if you're looking at this, it's now increasing from left to right, the size, because you're going from smaller to bigger, because cations are most often found on the left-hand side and anions are found on the right-hand side, and they continue to increase from top to bottom because, again, still more electrons at the bottom of the periodic table. So here's this lovely diagram. I'm sure if you look really closely with one eye closed, you can see the colors. The pink color is the cations, and the blue color are your anions. And if you look at the gray color, it is its original size as an atom before it became an ion. So you can see the trend visually here of both the atomic radius and the ionic radius. The next trend is the ionization energy. And if you think of ions as being the currency of the periodic table, some elements are really, they want to give up their money because they get more money when they give it up, and other money being ions, and other elements really don't want to give up their money or their ions because they're really close to their goal. So the first ionization energy is the energy required to remove that very first electron from an atom versus ionization energy, which is the energy required to remove any electron from a gaseous atom. The trend is the first ionization energy as well as ionization energies increase from left to right and decrease from top to bottom. That means if you're looking at the periodic table, that francium has the least ionization energy, with fluorine having the most. If you also look at this, elements that have lower counts of valence electrons, like the alkali and alkaline earth metals, are more likely to give up their electrons because they are going to reach that 8 is great by losing their electrons, versus your column 16 and 17s, which are really close to 8 is great because they just need 1 or 2 more electrons. They are not willing to give up their electrons, so they have very high ionization energies. And ionization energy and electronegativity all come down to the rule 8 is great. Remember, atoms will gain, share, lose electrons in order to get to 8 electrons. It's kind of like if you ever watch Game of Thrones, it's the game of electrons. They barter, steal, and organize each other in order to get to 8 electrons. So if you're looking at compounds, if you're looking at ions, if you're looking at everything that an electron or an atom does in the periodic table, it is primarily to get to a noble gas configuration, which has 8 valence electrons. If you're looking at these, it really does impact the electron configuration. So if you're looking at lithium, which is in the second row, first column, so it's got the electron configuration of 1s2, 2s1. Lithium's going to lose that 2s1 and have 1s2 with a 1 plus charge, 1 plus charge meaning it is losing 1 electron. Now, if you look at helium on the periodic table, the electron configuration for helium is 1s2. So by losing 1 electron, lithium now looks like helium. Fluorine, if you look at fluorine down here, it's an anion. It's gaining an electron in order to look like a noble gas. So the electron configuration for fluorine is 1s2, 2s2, 2p5. Now 2 plus 5, if you're looking at the same level of periodic table, 2 plus 5, so 2s2, 2, 2p5, 5, 2 plus 5 is 7. How many does it need to get to noble gas configuration, which is 8? It needs 1. So it takes 1, which is what this -1 means down here, and now it has 2p6. Now it is mimicking a noble gas because it's 8 valence electrons. So moving forward, electronegativity, that indicates the relative ability of an element to attract electrons. It is the exact same trend as ionization energy. It increases from left to right and decreases down the group. Again, francium has the lowest electronegativity. It just isn't very attractive to other elements. And fluorine has the highest electronegativity. So here's the highest with fluorine, lowest with francium. It is the exact same trend as ionization energy. They go hand in glove. And those, my friends, are the trends of the periodic table.